There are lots of different ways to describe a graph and a lot of words we could use. So we're going to go through several different words that we use with graphs. So the first one is positive. When we say a graph is positive, what do we mean? And what we mean is that we have positive y values. So here's our x-axis, and this is when y equals 0. So if we want to know when the graph is positive, that's when the y values are positive, so the y values are above the x-axis. So we read graphs from left to right, so if I start over on the far left-hand side, the graph is coming in from negative infinity, and it's above all the way until we get to x equals negative 4. At negative 4, we have a removable discontinuity, a hole. So I would say this graph is positive from negative infinity to negative 4. Now I'm using parentheses because you can never actually reach negative infinity, so you can't equal it. If we equaled something, we would have a bracket. At negative 4, you can get closer and closer and closer to x equals negative 4, but you're not actually going to get there because that's where the graph is undefined. Now as we keep going from left to right, you'll see that after negative 4, the graph stays above the x-axis again. So the x values where it's positive will start again at negative 4, not touching negative 4, and will go all the way until x equals 0. Now right here you can see that the graph actually exists at x equals 0. There's a solid point there. So we would do negative 4 with a parenthesis and 0 with a bracket. So we keep going. The graph is clearly below the x-axis over here, all the way till we get to right about here, and we're going to estimate what that is. So this is 1, 2, 2.5. So when the graph is above the line, let's say that it passes at x equals 2.5, then it's not positive at 2.5, it's after 2.5. So I'm going to use a parenthesis for 2.5, comma, and then out here I'm going to assume that this is 3.5. So the graph is above the x-axis from 2.5 to 3.5, but not including either of those points. So we have a parenthesis. And then the graph is negative again. So there are 1, 2, 3 intervals where this graph is positive. If we're looking at where this graph is negative, that would be negative y values where it's below the x-axis. So over here we're taken care of. The graph is below the x-axis over here, starting at 0 but not including 0. So we'll do parenthesis, 0, comma, until we get to 2.5. Now the graph is at 0, 2.5, so we're not going to include that. So 2.5, parenthesis. Then the graph is above from 2.5 to 3.5, and then it's below from 3.5, not including 3.5, to 4, but it does include 4. So parenthesis, 3.5, comma, 4, bracket. A lot of people confuse positive and negative with increasing and decreasing. Increasing means that our y values are going up from left to right. As x increases, so does y. As x goes up, y goes up. So x increases from left to right. We have negative numbers here, positive numbers here. So we need our y values to go up as well. So as we travel, the y values are going down, so this would be decreasing. So I'm going to use this interval for part D, which is decreasing. So negative infinity to negative 4. From negative 4 to right about in here, and let's call that a negative 0.75, my y values are going up. So for increasing, I'm going to say from negative 4 to a negative 0.75, and we're just estimating. Okay. At negative 0.75, the graph is not increasing, nor is it decreasing. It actually has a slope of 0 right there. From negative 0.75 to x equals 0, remember we're listing x values but looking at y values. So from negative 0.75 to 0, from left to right, the graph is going down, so it's decreasing. So negative 0.75 all the way to 0. Now some people use parentheses here and some people use brackets. It's not going to matter when you take the AP test which way you go here. When they ask this or multiple choice, I've seen it both ways. Right here, I think this should be a bracket, but if you put a parenthesis, we'll know what you mean. Okay, starting over again at 0, and I'm going to use a parenthesis here because it doesn't actually touch 0, the graph is going down all the way till x equals 1. The y values are decreasing. So from 0 to 1. Then at 1, you can't say that it's including it, which you come into the same problem that you do up here, because at 1, is it decreasing or increasing? You don't know. So we're not going to include 1. Now from 1 all the way to 3, x values of 1 to 3, the graph is going up. It is increasing. So I'm going to say from 1 to 3. From 3 to 1, 2, 3, 4, from 3 to 4, the graph is decreasing. And my honest inclination is to just leave this as a parenthesis, but you can go either way. I've seen it both ways. Okay, concavity. Concave up, concave down. Concavity is about the shape of the graph. If something is concave up, that means the bowl shape is up of the graph. It doesn't have to have both sides of the bowl. It could just look like this, or it could just look like this, but it is bowl shape up. So if you start looking at the graph from left to right, it is bowl shape up right here. But the graph doesn't exist at -4, so you still have to have a break there. So I'm going to say that we are concave up from -infinity to -4. But it stays concave up in here, but at some point in here it switches. And I'm just going to estimate where that is for the sake of our descriptions. Normally you would do this and figure it out algebraically, but I'm going to say it switches at -2 to bowl shape down. So I'm going to say from -4 to -2, we are bowl shape up, concave up. Now from -2 to 0, we are bowl shape down, concave down. Again, you don't have to have both sides of the bowl. It can be part of it or this part here, but we actually have both sides here. So it is bowl shape down, concave down, and we're going to say that is from -2 to 0. Now if you keep going, this part of the graph is also bowl shape down, concave down. So from 0 to 1, not including 0 nor 1, the graph is concave down. Now these two pieces are linear, they're straight lines, so they don't have any concavity. There's just strictly a straight line. Okay, points of inflection. Points of inflection are defined as places where you change concavity. So the graph has to go from concave up to concave down, or concave down to concave up. And this graph has one point of inflection. We're concave up, and right here we said we were going to estimate around -2. The graph switches from concave up to concave down. So x equals -2 is a point of inflection. Now here the graph is concave down, and we don't have any more changes in concavity where the graph actually exists even, so we have one point of inflection. Cusps. Cusps are defined as basically sharp turns. So what you're looking at are for places where the slope coming in from the left-hand side and the slope coming in from the right-hand side don't match. So if you pick a point like this, the slope is actually, the graph is flattening out and you have a slope heading towards 0. If you come in from the other side, the same thing is true. The slopes match. But if you look down here, the slope coming in is negative and getting steeper. If you come in from the other side, it's positive and you have a sharp turn. So this sharp turn is a cusp, and it happens at x equals 1. You can see there's one other cusp right here at 1, 2, 3 at x equals 3. We have another sharp turn, so x equals 1 and 3. So we have two cusps on this graph. Okay, if we keep going, you may have learned